So hello, I'm John Mainzer. I'm going to talk to you about some work on retrofitting some degree of multi-thread support to HDF5 library today. So, as I'm sure most of you know, at present, HDF5 library is fundamentally single-threaded. So, it survives in a multi-thread environment by setting up a global mutex and allowing only one thread in the library at once. And the interesting point on that is that this constraint is also applied to wall connectors. And what I'm be talking about today is aimed at starting to relax that constraint. Okay, I'll try to be good. So, true multi-thread support has been requested for a long time. Those of you who work with multi-thread development know that if you're developing from scratch, it's not too bad. If you're trying to retrofit it on existing code, it's all understood, not too big. It's unpleasant, but you can do it. HDF5 library, however, is quite large, not as well documented as it should be, and as a result, the task is daunting. And that's the reason why there's been no progress beyond the global mutex today. However, wall layer changes things. If we were to push the mutex down a little bit below wall layer proper, that would allow us to let multiple threads into a wall connector simultaneously, assuming the wall connector is able to do that. Looking into it, there's a fairly small set of packages: indexing, error, property list, context, and wall layer proper, which are the minimum that are needed to provide that capability. There's some other ones we'd like, but they can wait for another day. So I'll get this, there we go. So Lifeboat's trying to do this. We're planning on retrofitting multi-thread support of required packages, push the mutex down, and we're developing a bypass fault to allow limited multi-thread I/O on HDF podcasts. I mentioned the bypass fault, so I should go over that very briefly. There's been some discussion about there being two types of balls, terminal balls and pass-through balls. Bypass ball is basically the idea, which has been applied for some time, is that if you query the HDF5 library, you can find the location data. And once you have that data, you can go off and do your IO. And what the bypass ball is trying to do, is put back in the wall connector and make it transparent. In this particular case, we're assuming multi-thread involved there. That's not essentially being with we can try. Not having any value whatsoever. Yep. Good. All right, I couldn't rightly tell from my perspective. So, phase one, which was a SBIR grant from DOE, which is already done, that was directed mostly at trying to scope out the problem. And to nobody's surprise, it's a bit rougher than one would hope. First, found lots of interactions between packages, more than we'd hoped. Data structures, which, put it gently, were not designed with multi-thread in mind. Callback functions on public APIs are particularly entertaining because you have no control on what's in the callback function. And if you're holding a lock, well, who knows what can happen. Particularly an issue with the iterators. Bottom line on all of this is need to use atomics to the extent possible, as little locking as possible. And it may be appropriate to do some reworking of some APIs for the multi-thread case. RFCs that I wrote during that process are on GitHub. You're welcome to go take a look at them. I would comment that while the problem discussion is pretty good, I would say most of the design work is going to get thrown out as continue to think about this stuff and come up with better solutions. Phase 2 is in progress. Objectives are pretty straightforward. Hope to have a working prototype within a year and release it for comment. Get some input from you folks, what we're doing wrong, what we're doing right, what we should change. And then the plan is to contribute it back to the HDF5 library. In parallel, we'll be implementing the bypass ball, its initial test case, demonstrator, and eventually as a product. So, status. These next two slides are intended to give you current thought on how we're going to be proceeding with this and give you status. No plan survives contact with the enemy. I know it's going to change, but this gives you an idea of how I'm trying to proceed with this. So I started out with the index, as that seems sort of the most basic of the structures, and looked around for a lock-free hash table. Didn't see one that looked like it was sufficiently mature that I should use it. In any case, it's good exercise for me to do my own. So I've implemented a prototype. It's on GitHub. It's been integrated into H5i, is now passing serial tests. I'm in the process of finishing the retrofit of Multithread on the H5i. And we'll then write some test code. All this being done in the serial build, because if I were to use the thread safe build, I would only let one thread in at a time. Need to do the same thing on H5e. And then once I have that done, I can finish up the hash table, because if it's going to go in HDF5, it should use the HDF5 error reporting and such. And then we need to set up a multi-thread configure option in the HDF5 library and start putting together the infrastructure. Just push the mutex down below the various packages. Once we've done that, calls into H5i and H5e should not hit a mutex unless the call goes further into the library. From there, it's pretty much what you guess. On to H5p. There's some particularly unpleasant data structures there, so I think there's going to be a rewrite, which, in addition to multi-thread, I hope will give us some performance enhancements and context and vol layer, and then start working on the bypass ball, or testing with the bypass ball, because that implementation is already in progress. So, thanks to DOE for supporting all of this. And there's a couple references for you. See the design documents and the lock-free hash table if you want to go play with it. It's going to be changing in the first few months, but by all means, have that. And thank you, and questions.
Two thoughts. Do you anticipate including in the sort of the pull request that this ultimately results in HDF, including in it like enhancements to the test suite actually set?
Obviously. Obviously.
And then a second one, do you have a sense, can you articulate now what you believe to be maybe one of the killer app use cases that would really show off wireless use?
Well, the one we are implementing right now is that bypass wall. And that particular algorithm has already been implemented with, if I recall, something on the order of factor of 10 improvement in throughput. I should remember the gentleman, Blue Brain folks. We presented that at supercomputing last year.
Sorry, did you say Blue Brain?
Blue Brain.
No.
Yep.
Awesome.
Anything else, or am I done?
Do you have any ideas about exposing this to folder plugins?
Plugins, I believe, for filtering. Now we're getting down to the question of making what's frequently referred to as the native ball multi-thread safe. That's a huge chore. I suspect that this bypass wall can generally be extended in that direction. It's going to be done piece by piece and incrementally. When that would happen, if that would happen, is going to be a matter of support and interest.
Okay, because I think there's a lot of specific interest in using multi-threads, standard compression, decompression in chunks.
So I'm curious, in that scenario, are you interested in multiple threads calling into the filter, or are you simply interested in a filter that executes multiple threads?
Possibly both.
Okay. One of them's already been considered. I mean, obviously, bypass wall could be extended in that direction as well.
This one, that case, possible to sort of keep it significant things on that's what they're down to.
The idea would be to set up a filter with its own thread pool, but there are issues there as well.
Yeah, I actually think that for that.
Great questions. Any other comments? Thanks, John, for bringing us back by time.
Thank you. Thank you all.